salts. An acid is a certain type of molecular compound. Most acids used in the laboratory are either binary acids or oxyacids. Binary acids are acids that consist of two elements, usually hydrogen and a halogen. Oxyacids are acids that contain hydrogen, oxygen, and a third element, usually a nonmetal. When you talk about oxyacids, that's when you get into using polyatomic ions. So, an ionic compound composed of a cation and anion from an acid is often referred to as a salt. A compound that contains one or more hydrogen atoms and produces hydrogen ions when dissolved in water. So, to elaborate on this, right, we're dealing with an acid, you're always going to have hydrogen, H plus, as your cation. So hydrogen must be present. So there are 3 rules for writing and naming acids. So 3 rules can help you name an acid with a general form HNX dissolved in water. And I'll talk about that a little more. HNX. H is the number of hydrogens, or we'll just say hydrogen for right now. N oh boy, is the number of hydrogens and that comes from the charge of the anion. And then X will be our anion. So the naming system depends on the name of the anion X, in particular the suffix of the anion name. So each rule deals with an anion with a different suffix, IDE, ITE, and ATE. So the first rule, when the name of the anion ends in IDE, the acid name begins with the prefix hydro. The stem of the anion has the suffix IC and is followed by the word acid. So for example, say we had HCl. Key thing here, we need to look at our anion, is chloride. So our anion ends in IDE, and it's a binary acid, so we're going to have hydro, the stem of the anion, chlor, and then IC, so hydrochloric acid. This is one word, hydrochloric acid. Second rule, when the anion ends in ITE, the acid name is the stem of the anion with the suffix OUS followed by the word acid. So this is where we get into our oxyacids. So, say we had H2SO3 And we know SO3 is sulfite. So this ITE is going to go to OUS. So it'll be sulfurous acid. And the third one, when the anion ends in ATE, the acid name, the stem of the anion, with the suffix IC, followed by the word acid. So, say we had HNO3. So NO3 is nitrate. That ATE is going to go to IC. So we'll have nitric acid. And here's just a chart with all three rules together with an example. So, say we had two examples here. We wanted to name the following acids. We wanted to name, let's say H. Yeah, better color than that. H. Cl and H3PO4. So we look. First one, we have a binary acid, and our anion is chloride, so it ends in IDE. So it's going to be hydrochloric acid. And we'll do another one since that was the one we did in our last slide. We'll say HF will do. So our anion is fluoride, ends in IDE, so it'll be hydrofluoric acid. Now this one, our anion is phosphate. So ATE is going to go to IC. So it'll be phosphoric acid. Now a base. An ionic compound that produces hydroxide ions when dissolved in water. So for a base, we're going to have a cation and an anion. And that anion will be hydroxide. So, a few examples of this. Say we had KOH and Fe parenthesis OH parenthesis 2. Okay, so we look here, we have our potassium. And then we know OH is hydroxide. Now the next one we look at, we see we have iron and hydroxide. We know iron's a transition metal, so we need to make sure we have our charge in parentheses next to the iron. So first thing we need to do, we need to look at our cation, or sorry, our anion. And our anion is hydroxide, so we know it has a -1 charge. That's where this 1 goes. And where this 2 come from? It came from the iron, so that's a +2 charge. So we'll have an iron 2 hydroxide. And that concludes our video on naming and writing acids and bases.